Okay, our final topic in important details deals with forces in the passive zone. And the passive zone is the toe of the slope, right down here, and you can have a triangular, you have a triangular wedge when you're doing the method of slices. And under certain conditions, the resultant force on the base of the slice may become either very large or negative. And this happens when the resultant force at the base of the slice becomes very close to the direction of the inner slice force. So if these things are perfectly parallel, then it causes kind of a discontinuity that can make that force get really large or very small. Now that is a problem because the trial and error solution for the factor of safety may not converge. Now let me clarify here. We are talking primarily about like Spencer's method, or well, there are other methods that have a trial and error. Any of the methods that use a trial and error solution for the factor of safety, so Bishop's, force equilibrium, or Spencer's method. It could be that this discontinuity makes it so they just can't converge, and or the forces may become extremely large and produce unreasonably high shear strengths in frictional materials, because the shear strength is a function of the normal stress times the tangent of phi, and or the forces may become negative, which would give you tension. Now, if this occurs, UTexas output will give you a series of warning messages. Like if you look in the output file, it'll say warning, tension detected in the passive zone, and you need to go back and look and be careful about it. And I should also say that remember with Spencer's method, the side force inclination of this resultant force on all slices is parallel. So you end up with a single side force inclination. But if you use a different technique like force equilibrium, that side force inclination can be downward here, and then once you get down to this point, it typically is upward. And so so this is especially a problem when you're dealing with Spencer's method. Solutions: change the slip surface inclination, use a non-circular surface. What that does is it changes. You can come up with a different angle on this bottom slice, or use the ordinary method of slices, or change the side force inclination. Use one of the techniques such as a force equilibrium method. Now these aren't available in the educational version, but if you're using the full version of UTexas, that would be available. So this is actually when you have the full array of slope stability methods here, this can be a fairly easy thing to deal with, but it's something you need to be aware of when you do full-blown slope stability analysis, and you got to carefully monitor that output.